Okay, so it's a new unit we're going to begin today, and the major heading is algebra. You've probably heard a lot about it. It makes a lot of appearances in movies and things like that. So it's my job really to debunk some of the myths about algebra being insanely hard or inaccessible. And what we're going to do is just build this up slowly, and hopefully algebra is logical, and you'll find hopefully that it's also something that you already do intuitively. All right, so today we're going to write expressions, and if I said that let x, this letter here, x, be the current age of Mr. Miller, how old will I be in 15 years? Now, you don't know how old I am, I presume. All right, so you might look at me and go, oh yeah, he looks really young. All right, must be only 25 by the looks of him. Or you might think, oh, he looks like a grandpa. All right. So the only thing is, you know that X is my current age. So how old will I be in 15 years? We're going to take the current age of Mr. Miller, which is X, and add 15 years. And that's the only thing we can say with any certainty at the moment, is that in 15 years, I'll be X plus 15, where X represents the current age of Mr. Miller. And what we've done there is constructed our first algebraic expression. Okay, this can't be solved unless I tell you what my age actually is. Okay, so there is no solution to this problem. So some definitions. That x that I used is referred to often as a pronumeral or a variable. That is, its value can vary. Okay, and we often use letters or symbols. Okay, so letters you'll commonly see X, Y, Z, but it can be any letter, A, B, Y, etc., etc. But often symbols are used, and we can use Greek symbols. Okay, so this is the Greek symbol lambda. This is theta as well. That's one we use in a topic called trigonometry. Alpha, etc., etc. So there's all sorts of different symbols that we can use, okay? And we use them for numbers that we don't know the value of, okay? Now, the unknown is the actual number that the pronumeral represents. So if I said that the unknown in the other case, x plus 15, if I said the unknown is, and I'm 42 girls, okay, then the unknown, or x, is equal to 42, right? So that's what the unknown represents, is the actual number the pronumeral represents. Now, it's really important that there's some basic notation with algebra that you need to interpret. Now, when you see 2m written like that, what that actually means is 2 lots of m, or 2 times m. So you see a number followed by a letter. What we presume is that in the middle of the number and the letter, there's a multiply sign, okay? And it's not a case of sometimes, it's always. It's always presumed that there's a multiply sign. So 2m always is equal to 2 times m. It's never going to be 2 plus m. Okay, so it's not equal to 2 plus m or 2 minus m, or Mr. Miller, today what is the sign between the 2 and the m? It's always multiplication, and that's a universal thing, girls. That's not just a Sacre-Cœur thing or a Mr. Miller thing. That is everywhere. Okay, that's the language of mathematics. All right, notice here that we've got m plus m plus m plus m plus m. That's the same as 5 lots of m. Okay, and 5 lots of m is simply written as 5m. Finally, we will use a fraction symbol, the vinculum, instead of divide. So that sign there we rarely use in mathematics beyond primary school and a bit of year 7. So 5 divided by m is the same as 5 on m. Okay, and again it goes without saying that if we were to do division, 4 divided by 2, that's the same as 4 on 2 as a fraction, and 4 on 2 as a fraction is just 2. So we want to get as used to the fraction notation as we can. So what we're going to do now, girls, is simply write some expressions. So we've got a number plus 10. Now you might be thinking, what's the number? What's the number? Until you tell me what the number is, I can't add 10 to the number. But actually, let's say that let x equal the number. And now we can write an expression for this. a number plus 10 is simply x plus 10. That's a number plus 10. So x plus 10. Now remember, I can't further proceed on this until someone says, oh, and the number is blah, blah, blah. So x plus 10 is the only answer I can provide for this. And again, this is what we call an expression. 10 less than a number, okay? So what we're going to do is start with a number, let's call it x, and do 10 less than it. Okay, so x take 10 is 10 less than a number. X take 10, right? So that's our expression there. And again, we can't simplify that. Okay, that is the best we can write the answer, x take 10, until they tell us what the number actually is. We can't actually answer this problem better than just writing x take 10. Right, a number multiplied by 4. So again, our number is x, and we're going to multiply it by 4. But let's note that we, in algebra, don't write this multiply sign, so we would write x4. And another convention in algebra as well is when we multiply, we actually write the number before the letter. So that would go the other way around, noting that x times 4 is the same as 4 times x, which is the same as 4x. So the better way to write this expression, or the more acceptable way to write this expression, is 4x. You'll see reasons for that a little bit later on, but again, it's a convention thing as well. If you write that like that, someone will sort of wonder why you didn't write it the other way around. It's an accepted convention, so you just need to get used to that one. All right, a number divided by 6. So we've got a number, which is x, and we're going to divide that by 6. Now, remember what I said about this division symbol here? We don't really see that in mathematics in senior school. So what we want to do is, instead of writing it as x divided by 6, we're going to write that as x over 6. Okay, and noting that that is not the same as, or will be completely different for 6 over x. This means how many times will 6 go to x? This one here means how many times will x go into 6, okay? So you can't just reverse those ones around. It has to be in the order specified. Okay, so this is a number divided by 6. It's got to be x split 6 ways. All right, this time around we're adding 4 to a number and then dividing the result by 3. So I get x plus 4. So we're adding 4 to a number and then dividing the result by 3. Now, what's the issue here? Well, order of ops will say that we've got to do 4 divided by 3 first of all, but what we want to do is add 4 to a number. So how do I do this? What I've got to do is make sure that order of ops says that the 4 gets added to the x before we divide by 3. Now remember, what I can do is rewrite this in more sort of senior school notation, which is it's x plus 4 all divided by 3. So we're going to write it as x plus 4 all divided by 3. So add 4 to whatever x is, and then split it 3 separate ways. So this is correct, but this is better. Okay, this is more senior school notation. All right, this time what we're going to do is subtract 2 from a number, then multiply our answer by 5. We've got a number, and we're going to subtract or remove 2 from it. And then, once we've done that, because that's saying we're going to do that first, we're going to write or multiply the answer by 5. Now remember, with mathematics, what we don't do in algebra is use that multiply sign. So we're going to write that as x take 2 with a 5 there. And remember I said also that the convention is that x take 2 all multiplied by 5 would be the same as 5 multiplied by x take 2. All right, and then we write this without a multiply sign. That's written like that. That's actually the more correct way of writing it when compared to this. Now this is correct, but this one here meets the conventions. It's just better. It'll be like me saying to you, I'm just trying to think of an example. Like in English, I say to you, pen in pencil case. What's a better way of writing or saying that? It would be place the pen in the pencil case or something like that. So in algebra, this and this mean exactly the same thing, But this one here just explains it better. Now, again, I'm sure that you don't know why that's different from that. And you'll see reasons for this a little bit later on and why this has or is a convention. Okay. So the work today will be to practice writing expressions. There's a linked worksheet there. So you can grab a link for that, and there's answers also so you can check your solutions.